you have stream of data about air quality, but for all practical purposes, it's going to be useless. Because you have stream of data in one. Good morning. Okay, so you are still alive, and at least some of you are not asleep. I know you were taken from your classrooms where you were supposed to study things to get a job, and instead of this, they told you to come here and what? Yeah, this is a serious thing because majority of you came to university with only one thought: get a job. The best would be probably in data consulting services in Noida. By the way, living in Noida is not fun. When there is a torrential rain, then whole Noida has no Wi-Fi. And how can you live without Wi-Fi? You see, I am old enough to know that it's possible to live without cell phone and Wi-Fi. But for you, it may be a very scary thought, you know? I think that the majority of you, when you were confronted with the thought, tomorrow morning, when you wake up, there will be no Facebook, because there will be no internet. You probably, it's worse than seeing a horror movie, something like Friday the 13th. More scary, yes? I know. So you came here to get a job, but ladies and gentlemen, let me put this to you. Getting a job is not everything. Getting a job is just temporary commitment to being associated with some idiots who will be telling you what to do. I'm glad that you share my feelings. Yeah. If you are told to come every day at 9, and at 9:03 they will take money from your salary. Yeah. And then you're supposed to stay till your boss is staying, the Japanese way. You know, in Japan, even if you have nothing to do, if your boss, if your leader of your group is still working at 7 p.m., you cannot leave. Because if you leave, this would be offensive to your boss who is working. So you are waiting till 7:30 to go with your boss, drink a lot of sake and get drunk. And then you wander around Pizza area aimlessly trying to figure out who you are and where's your home. I have seen this last week because last week we were with President Gansha, we were in Tokyo for a week and we have seen plenty of those, yeah. Thank you. So guys, life is not about a job. Yeah, I know this may be sort of strange to hear this, but life is not about a job. Life is about thinking, about expanding your minds, about gaining knowledge. And it doesn't have, by the way, to be yet another version of Unity Engine that you're going to be studying. Yeah, I know, studying Unity Engine and developing characters that will be moving and will be killing other characters. It's cool. Absolutely. I have never done it, but I appreciate this. But knowledge is important. So the fact that you are here, you can treat as a punishment or as an opportunity. An opportunity may be to open your mind, to see things differently, to get some perspectives on things which are happening around you. Maybe this will change your vision of the world. And remember, it's gonna be you guys who will be shaping the world which is coming. And what is coming is not nice. No. Your parents, when they were your age, had this beautiful future in front of them because everything was getting better. Let me put it this way. Right now, everything is going straight to hell in a handbasket. This is the world around you. With the climate changes which are coming, with the conflicts, with the lack of water, we are coming to tough times. And it's gonna be you guys who will be facing it. So the more knowledge you have, the more reflection you have, the better you can use your brains on your own without being told what to think, the better you will be and the better chance you have to survive in the world which is coming. So maybe instead of falling asleep or firing up another application on your cell phone to play some games, listen to what's going to be told and reflect on it. Thank you.
Awesome.
Thank you so much, sir. That indeed was insightful, and I'm sure each one of our budding researchers and young Vertos agree to that completely. Thank you so much, sir. Thank you very much. With no further ado, I now request Professor Kaviraj Gupta, Pro-Vice Chancellor, Lovely Professional University, to address the audience.
Before we go ahead, let me throw a quick light on the credentials. A leading light in the field of technical and higher education in the country, his research-focused approach and an insightful, innovative intervention of technology in education has won him many accolades and laurels. He holds a PhD in bioinformatics and did his MTech in computer-aided design,
Interactive Graphics from IIT Kanpur, and BE Mechanical Engineering from MIT's Gwalior. Having a flair for endless learning, he has done more than 50 certifications and specializations online on IoT, augmented reality, gamification, machine learning from University of California, Wharton School, University of Pennsylvania, deep learning, AI, Google, machine learning group. His research interests are in the areas of robotics, mechatronics, bioinfographics, IoT, AI, ML, just to get started. He has 7 books on IoT, mobile robotics platforms, biomedical sensors, and machine learning with data analytics. With 150 plus patents, 100 plus other publications, 4 granted copyrights, he is an epitome of knowledge and wisdom. I now request the man of excellence, Dr. Laviraj Gupta, to please grace us on the stage. Thank you, sir.
Good morning, all. Why all the time you want me to repeat that again, that I didn't hear that? Good morning. First of all, a great round of applause for the vibrance and energy of Dr. Marshall. Believe me, all the people who were sleeping, he might have awakened them and brought them to this room mentally and physically both together. Isn't that true? So one more round of applause for him. I didn't ask you to scream. Did I ask you to scream? Don't go out of the loop, please. He talked about 2 basic things. He talked about Friday the 13th as a scary movie. Back in 1993-94, there was a virus called Friday the 13th. And you know, all those x86 systems, 286, 386, 486 kind of systems,
they are all infected by that virus. And if Friday occurs on any of the 13th of the month, the entire day, the PC would not boot up. And you know what people did? That if the Friday the 13th is happening tomorrow, they will change the date of the PC. Why I'm talking about this? That the technology has changed drastically because the shape of viruses, the shape of malwares are now completely beyond comprehension of anybody. But that lends you into grandest of the opportunities. That makes you, I use this word, forget about being unicorns. You all are my soonicorns. Because soon you'll become a unicorn one day. I'm pretty sure. But three things. I've got 3-point agenda. Are you all ready with me? The very first point in the agenda of anybody studying computer science. Do not be syntax smart, be logic smart. I developed the same codes using Fortran 4, Fortran 7, DBase 3, Foxbase, and I still code using Python and Go language. I do not believe in becoming syntax smart because languages will come, languages will go. You know how to implement an if statement or where to implement a while and not using do while at that point of time. If you know that, forget about what kind of languages may come and go. You'll always be the front runner in developing logics. The second very important thing is you need to unlearn and relearn every day. Go get yourself registered and subscribe to newsletters. You are lucky. For us, during our days of IIT Kanpur, if we needed an information, we used to wait for 2 weeks for the information. But now, your entire mobile is information indented. Go and subscribe to newsletters and read something what is happening. Very latest. To my utmost surprise, today in the morning, when I was going through a newsletter, Medium Digest, they told me that there is a brand new library which has come up with Python, and it is named as Ice Cream. And that ice cream, go and read about ice cream. It really comes in handy for anyone who's debugging his own code. Marvels. Be logic smart. Be in the mode of unlearn and relearn. And keep yourself abreast. Because by the time I'm talking to you, technology is changing outside there. We need to be that akin to the lightning pace. And third, and the most important thing, which would make you soonicorns. All of you have heard about Darwin's theory? Yes or no? The Darwin's theory is the theory of existence. Darwin talked about that you need to struggle to exist. But I redefine, refurbish, and retune that theory because in today's context, the theory would be not of existence. The theory would be of coexistence. You need to collaborate, you need to cooperate, and you need to co-create knowledge. Being into computer science, nobody stops you to explore hotel management or culinary arts, wherein you can take your logics there. Nobody stops you to barge into agriculture, to go into genetics and genetic engineering, which I did in those good olden days of 2003, 2004. And I took my logic to genetics. I am pretty sure that these kind of conferences, which I must appreciate. Give a good round of applause for Team Dr. Rajiv Sethi, Dr. Siddhar, and all the HODs and HOSs, all the faculty members who have conceived this and have successfully planned the 6th edition of International Conference. More importantly, To end my note, my outro is a conclusive statement. People say that the world is being run, the world will run, and the future of this entire humanity and the globe earth is on the word called IoT. All of you know about IoT? Okay, somebody said no, IoT is Internet of Things. I do agree, but I have my own version to it. Yes, the world is being run by IoT. It will be run by IoT, and the future of humanity belongs to IoT. And my definition of IoT is Indians of tomorrow. And that is what you are. I wish you all the very best, and listen to each and every word, because then only we'll be able to game change the entire scenario of computing and taking this world to the next level. Wish you all the very best. Good luck and Godspeed.
Thank you so much, sir. I must say, to be the front learners, the way you've told us to unlearn, to make sure that we coexist, to collaborate, and the new definition that you've given all of us for the Indians of tomorrow, that indeed was an enthralling speech. Thank you so much, sir. I request all of us to please give him a huge round of applause. The gratitude, the love, the reverence, the honor are small words that we all have in our minds today. With the presence of each one of these esteemed dignitaries here, who are here to enlighten us with their knowledge and wisdom. To express this, we are short of words, but we're not short of our expression. For the same, I request Dr. Raviraj Gupta, Pro Vice Chancellor, Lovely Professional University, to come forward and felicitate our guest of honor, Professor Marcin. Ladies and gentlemen, please give him a huge round of applause to express our gratitude for the presence. We are indeed honored to have Sir amongst us today. Thank you so much, sir. It's an honor to host you at Lovely Professional University. I now request the Pro Vice Chancellor, Dr. Raviraj Gupta, to please honor Professor Maria Ganza for joining us here for booth 100. Ma'am, it's indeed an honor and privilege to have you amongst us and to host you at this international conference on computing sciences. Thank you so much for your presence, ma'am. Give them a huge round of applause, ladies and gentlemen. I request sir to
somebody telling you, hey, you scratched my car. Well, you know, there are bad people there who bring their scratched cars to parking lots, and then on the way out they say, hey, you scratched my car, you need to pay me. And then you have this thing and you say, no, sorry, man. We have here full documentation.
To thank each one of them, I would request the COS, School of Computer Science Engineering, Dr.
I extend my very hearty vote of thanks to Honorable Chancellor Sir, worthy Pro-Chancellor Ma'am, for always encouraging us to conduct such kind of mega events and research activities. I also thankful to all the speakers for their gracious presence and sharing their wonderful, insightful information with our students and us. So a big thank you to Professor Marcin Papriski for sharing his insightful wisdom on the meaning of life and vision. Like, life is not just to get the job, but also it is to gain the knowledge and set the visions. So I also express my thanks to Professor Maria Genza for being over here and express her presence over here among our students. I also convey my I am grateful to Ms. Richa Jain Gupta, Dr. Kamalnath Samarakun from University of Peradeniya, who expressed his wonderful knowledge with our faculty members, students yesterday. And not only he shared his wisdom, but also he actually contributed and collaborated a lot in this conference. So for this, I am thankful to Dr. Kamalnath. I also wish to express my gratitude to Dr. Sriram K. Vasudevan, Professor Richard Hill, and Rupert Ward, who will be delivering the virtual talk with our students and researchers. And with this, finally, I would like to thank this opportunity to place on record our hearty thank to our worthy Pro-Chancellor Sir, Pro-Vice Chancellor Sir, Dr. Laviraj Gupta, for his continuous guidance and throughout this event and his blessings. I am also thankful to Professor Rajiv Sopti. He is our Senior Dean and Head of School Computer Science Engineering, for his perfect logistic support and guidance throughout this Booth 100. I am also extending my warm thanks to all the CUSs, HODs, and my colleagues for their enormous cooperation in the organization of this event. So, well, friends, an event like this cannot happen overnight. It requires lots of efforts and tremendous exercises and planning. So we have been fortunate enough to be backed by a team of very motivated and dedicated colleagues of Computer Science Engineering School, and who know their job and result oriented. So last but not the least, I would convey my sincere thanks to all the researchers, scholars, students, and academicians who contributed their work in this conference and made this event a grand success. So with all these closing remarks, I conclude my words by thanking everyone who directly or indirectly involved to make this Booth 100 a grand success. Thank you.
Thank you, sir. Indeed, that was a true expression of our gratitude on behalf of all of us to our esteemed guest. With that, I request all the dignitaries to please join us on the sofas ahead to be comfortable and join us for hearing the keynote speakers one by one. I request Professor Marcin, the man who serves the chair of ICCS Poland, section of Computer Science chapter, the man who's contributed with 500 plus publications and been to 500 plus international conferences, to come forward and propose this keynote address. May I request for your presence, sir? Sure. May I request each one of us to please make sure you give him a huge round of applause to welcome him. you, sir. Over to you, sir.
Okay, I want to see my presentation.
It's right here.
Okay. Which one is?
They're all working. They're all working.
Okay, you can see the title of my presentation. It was here a moment ago. Yeah, the title of the presentation will be In Search of Perfect Paneer. Well, I am a foreigner, so I came and I fell in love with paneer. But there are probably 100,000 different ways of preparing a paneer. So I figured out I need to find the best one. And each time I'm in some place, I am asking the local, what is your best paneer? And they serve me something, and I will tell you, at this moment, number one paneer comes from a restaurant in Missouri. Who has been to Missouri? Okay, there is a restaurant which is named Urban Turban there. The photo in the middle is from that restaurant, and the table there is the one that we were sitting with Professor Maya and had the best paneer ever. And if you go to TripAdvisor, there is even a photograph of a paneer like this. Oh my God, this was delicious. Of course, this was after a walk through Missouri, so maybe this was cheating, because if you're hungry, anything will taste good, other than Japanese natto beans, which is, anybody tried natto beans like from Japan? Anybody has been to Korea and tried fermented crab? So generally, there are two foods that I know that I will never taste again because I am not appreciating them: natto beans and Korean fermented crabs. Okay, so now I think I have control over this thing. Let's see if it's gonna work. Now seriously. Seriously, I wanted to share with you something. By the way, can you see it? And it looks good? Okay. So guys, I wanted to share. I have it here too. Okay. It's all confusing. Okay, so I wanted to share with you some knowledge about so-called federated learning. Yeah, they are taking away the chairs, so we will not come back there, okay? Maybe it's a sign that we should leave. No. So I will be talking to you about federated learning. The aim of this talk is to familiarize you with the concept of federated learning, and then tell you what is needed in federated learning to make it practical. And here we have an extremely skillful, knowledgeable professional from the practical side, from business. And during lunch, I will be very curious to hear from her her thoughts about practical aspects of federated learning. Okay, so let's start from something that you may know or may easily envision. Let's talk about machine learning. I presume that all of you in some way or another saw machine learning. One of the problems of machine learning is that in a variety of cases, before you get your results, it takes hours, days, it may even take a week to train a model. So already for a long time, researchers are studying methods, how you can split the work. So you combine the task, the computational task, and then somehow have each independent machine or node in a cluster or node in a parallel computer compute its own job, and then somehow to combine the results. So it's standard divide and conquer type approach, which means you split, give it to independent nodes, independent machines, then you combine the results. Now, what can happen is that either you do all the work and then combine the results at the end, which is rare, but it can also happen that you combine the results, then split the job again, do some calculations, combine the results, split the job, combine the results, split the job, combine the results, split the job, and then someplace there is stopping criteria. And by the way, at this moment, it doesn't matter which specific machine learning task it is. It doesn't matter what stopping criteria it is. What matters is that you can split those things and you can combine them, which means that you hope that your answer will come faster. Okay? General idea. Now, one of the early versions of distributed problem solving what comes from the time when majority of you were just an idea in heads of your parents, because if you count it, it's 2000, so 22 years ago, or maybe you were a scary moment of thoughts of your parents. Oh God, we're gonna have a child. Yeah, I know something about it. So anyways, a scary moment, we're gonna have a child, but you are not here yet. But Eric Cantupas, who worked on his doctorate, because this result is from a PhD research, did something like this. Genetic algorithms, he split the population between nodes of a parallel computer at University of Illinois Urbana-Champaign National Center for Supercomputing Applications. And then each node was calculating new populations of this genetic process. And from time to time, best results have been exchanged. This is how he was splitting the work and combining the work. Combining was through exchanging singular genomes, best genomes. Later on, this process became known as island version of genetic algorithm or genetic approach. Island version because the assumption was that each island is having its own population, and then the best genomes that are exchanged are like sailors who go to another island and multiply there. And I'm not commenting on this one, okay? By the way, I just wanted to suggest that the battery here is running low on this machine, so maybe something needs to be done. There is someplace power which is missing. Can somebody fix it? Okay. Okay. I hope that I'm not running from I think I'm running from this machine, so we're going to run out of electricity soon. So then I will do hand puppets. Okay. So, distributed machine learning, yes, oh, yeah, this guy is going to fix the problem. He is the fixer. Yeah, electricity is not coming from wherever it's coming. and it's not now.
Huh? Switch Annie? Huh?
Okay, apparently it's fixed. No, it's not fixed. Okay, so distributed machine learning is well studied. I mean, look, 22 years ago, it was all already studied. There is some work which is on how this can be done, and there is this thing coming from archive. And by the way, I will send, well, those slides are available, so anybody who's interested can get them from Professor Gauri-Matur or from Professor Garg, so you can get those slides. I'm ready to share them. It is also part of parallel computing, which is splitting the job and running independently on parts of the machine. Okay, so we have this. We can do this, but those methods that people studied for a long time are based on one assumption. And the assumption is simple. The owner of the data has full control of what's going on. So there is one owner of the data, one facilitator, and this facilitator will run machine learning. So we'll send jobs to different nodes that it owns, has full control over, and then we'll collect the results. Super. Except that this is not the world of today. For instance, all of you have smartphones. Each smartphone has 10 or more sensors, and those sensors are generating data. Now, this is fine, but the fact that you have this data, that you own this data, does not give you much. Because if you try to train something only on the data from your smartphone, you will not get good models. It's going to be useless in general. So now, the question is, can we do something about it?
And it should be working. Just trying it. Yeah, it's working.
Okay, I got the device. Okay, we will try to work with the device. Okay, so if you have $100, you can get yourself a air quality sensor. Because I just checked last night, and on Amazon, and it is specifically mentioned, ships to India, you can get a weather station with quality of air control. It's a box, looks like this, more or less large, for $100. Now think about this. I mean, you are engineers. Each and every one of you, $100 is not much. I know, because I know how many of you have Apples. If you have Apple phone, you can afford a quality of air sensor. Or you can ask your parents. Okay, guys, if you install this thing outside of your window, think with me. You have stream of data about air quality. But for all practical purposes, it's going to be useless. Because you have stream of data in one location. It's your data. You can try to use some machine learning to train something on it. But guys, if you have, let's say outside of your window in your dormitory, you have one point where you're going to measure things. Not much. Whereas Just if each and every one of you had a sensor like this, and you lived around town, around the area, then somehow we could deliver something interesting. There is also machine learning dedicated hardware, little things that are available, and those little things are, Intel Movidius I think is dead by now, but Intel was trying to do those little machine learning things which look like a pen drive. But there is NVIDIA Jetson Nano, which is also not very expensive, it's a small board. So everybody could put anywhere machine learning. But this machine learning is local. It will have limited capacity of reasoning. This means that we need something different. We need to be able to deal with a situation when there is more than one owner of data. Now, what happens here? You have multiple devices with multiple owners that have data which is important, but you need to get them together to get something valuable. Then there are the other sides. Let's say that you have plenty of images on various machines. You know, or you should know, that machine learning task is better if you have a lot of images. Let's say you're gonna study something, some classification based on images. Well, if you combine them, you can get good quality machine learning model. But guys, how you combine them if they belong to different people, and also sending them across the network may be a problem. Your network may be weak sometimes, all the time. How you combine them? Sometimes local images cannot leave the location. You cannot send them to the cloud. In India, you have hundreds of thousands of clinics. Each clinic has its own medical data. Most likely, this data is protected, privacy protected. You cannot send this data to the central cloud to do machine learning. This data has to stay where it lives. And also, different data can belong to different stakeholders. What it means is, let's say that you have multiple companies that use specific machine or similar machines. Well, they don't want to share the data about their machines. But if they use only machine learning on their one or two machines, this will not give you good models. We need to share without sharing. So a key point here is, okay, the first key point, wake up, look at me, hey. First key point is, distributed machine learning is relatively easy because all the data belongs to one owner. But if the data does not belong to one owner, we need to share without sharing. Okay? This is the problem. How to share without sharing. This is what federated learning is about. Federated learning, and now focus, guys, stop talking to your friends. Yes, I know this girl is beautiful, but at this moment, look at me, I am not beautiful, but at least you will get some knowledge and not get in trouble. Okay, so federated learning. Federated learning is an approach to train jointly a model without sharing the data. So this is where this sharing without sharing comes. You will get joint model, but without sending data to the central cloud, without sharing any data. How does it work? Okay, so here we have it. You have nodes, and each node will be training model on local data. And then they will exchange ideas how the model should be improved. So let's say that here we have apparently around 2,000 students. So if there is around 2,000 students, each one of you will train your own model and then make suggestion how to improve the joint model. I will take all of your suggestions together, average them, and use this to generate round 2 of the model. So from the initial, not knowing nothing, I get your inputs, all of you. You give me input, I produce new model, and I send it back to you. And then you train it again on your local data, send me suggestions for updates, I average them, improve the model, and send it back to you. And I repeat it round after round after round until there is a stopping criteria, the model stops improving. And now, look what happened. We all contributed to creation of one model, okay? There is one model, but none of you released any knowledge of your data. Your data remains private, but there is joint model, sharing without sharing. Why do we do this? Well, single owner of data, as I told you, may not be enough. So it may be not enough to have data from one source only. Model will not be good enough. And then there is this thing that we talked about during the initial talks about collaboration. And your chancellor was talking about collaboration as being important. Now we have in business the new business model, which is named co-opetition. What is co-opetition? It means that you are competing while collaborating. There are some areas where you are collaborating, but you are competing in another. I mean, think about this. We already started to talk. Let's say that there is this machine that is used by various tractor factories across India. And we want to do predictive maintenance. Do you know what is predictive maintenance? You don't? Okay, this is what you do. You put sensors on your machine and you let those sensors report the behavior of the machine. And then you use time series analysis and you learn that if there is certain pattern of data, then potentially something wrong can happen to your machine. Okay? It's doable. And this is important. This is important because instead of having machine which is broken, you can sort of this machine doesn't sound well. Let's graciously stop it, send engineers to check it, do some maintenance, predictive maintenance. So I predict that something may go wrong and I improve the machine, replace some parts, put some oil, whatever, and then I restart it. This is cheap. If the machine breaks during production, it's a disaster. So, what if I wanted all those companies that produce tractors to compete in the tractors? Some like Massey Ferguson, some they don't like Massey Ferguson. But all of them use Siemens machines to produce them. If they exchange the data and create better model for prediction, for the predictive maintenance, if they do this, then all of them are better off while still competing. There is no problem. They will be fully competing on the market, who has a better tractor, which way of marketing is better. It's okay. But for the goodness of the society, reduction of number of break-ins during production is good. So you have competition. And of course, you have also the data requirements, like the GDPR, by the way, for those of you who don't know, is the European rule, General Data Protection Regulation. And this is for privacy protection. So you cannot share certain data, it cannot leave certain locations because it's privacy. Very important concept in Europe. There is this thing here, which is very popular, which is areas of interest and taxonomy of federated learning. But we are running short a little bit on time, so I'm just going to focus on two aspects of federated learning. One aspect, scale of federation. I'm not sure if you know, but majority, if you have Android phones, your Android phones may be participating in federated learning for Google. Because what they do is they send a little model. Your phone will be using your local data to uptrain it and may send a proposed update back to Google. This is what's happening. Now, this is interesting because it's typically one bunch of training is around 5,000 devices. Most likely around 5% of them will never return the data in time. But they are building, for instance, word prediction. You know, when you are writing on a phone, and the phone may suggest to you the next word, how this is done. Well, it is federated learning by Google, among other things, that suggests what is the next word based on all of you, okay? By the way, those phones participate maybe once, maybe twice in a lifetime, and they are totally not recognizable. But we can have also a business scenario. A business scenario in which businesses agree to participate in federated learning. And then we have limited number of nodes, not 2,000, maybe 2, 3, 4, 5, maybe 100, but this is the max. And they will be cooperating in developing this model. Now, here, for instance, everything goes along with some agreements. So we are not talking about, you're being surprised that your phone participates in machine learning. This is about an agreement between businesses that they will be jointly developing things. And by the way, there is, for instance, an agreement between 10 largest pharmaceutical companies in the world that they will be building joint models to develop new medicines. They will be actually, pharmaceuticals will be collaborating while competing. Now, where is the research? Now, for those of you who may think about, hey, this sounds cool for some project or maybe for master's thesis, and where is the current research? Well, first, people look at various machine learning algorithms and they are trying to figure out how to do this in federated learning settings. Once more, sharing without sharing for various machine learning algorithms. So you have to be able to do things locally, then you somehow update something common, and then you have new version that you're gonna be locally uptraining, sharing, uptraining, sharing. This is your model. Data is not exposed. There are attempts to put federated learning in new application domains. So there is, of course, image processing, but image processing has many names. You can have image processing for plant recognition. You may have image processing for medical images. You may have image processing for something that you're going to see in a moment, and I will explain to you in a moment. Data privacy protection, you know what? Even if you just share updates, there are methods to figure out something about your data. So there is research how to further protect what needs to be protected. It's very interesting research, involves high-level mathematics and a lot of experimentation. You can claim that you can protect the bandwidth. If you are doing a lot of things locally and only share updates, then you are sharing only very little information. I mean, think about it. You are not sharing, you are not sending the whole model, you are not sending data, you are just sending a little bit, the updates to particular neurons in a neural network, let's say. There may be needs for various topologies. There may be groups of nodes. Here is one group, here's another group, here's another group. So maybe the group will first work together, with this group will work together, this will work together, and then they will be sharing updates, but from groups. How this will affect the machine learning process? Will it be better? Will it be worse? If it's worse, how can we improve it? All of this is research. Here is, for instance, one of the research areas when data is not well balanced. And let me give you one of the examples. We will not go through all of them. Let's say that you want image recognition and you want to teach it how to recognize a house. And you have data which has houses, let's say from Sikkim. Why Sikkim? Because it's cold there, they are in the mountains, and I presume that houses in Sikkim may look differently from houses in Kerala. Houses near Goa beaches probably look different than houses in Sikkim. So now we are doing, you see, what's happening here once more. Stay with me. We are not sending images from Sikkim, images from Rajasthan, images from Haryana, together to one cloud to train recognition of houses. No. In Sikkim, we will have images from Sikkim training local node. In Rajasthan, we're going to have images from Jaipur being trained there. Suddenly, those local models are very different. How we deal with it if we want to build one model for housing recognition across all India? Or think about animals. In Australia, you have kangaroos, but you have no elephants other than in zoo. In India, you have elephants, but you don't have kangaroos. So if you do images from India with animals from India, and Australia with wombat and whatever, koala bear. Yes, everybody loves koala bears. So we have plenty of koala bears here and no koala bears here. And then you have plenty of elephants and tigers here, and there is no elephants and no tigers here. Data is very unbalanced. How you build a joint model if the data is completely different in various places? Okay, this is all cool, yeah? Fine, plenty of academic research, academic, but then comes the reality. Here is from our project. We have a European project in which one of the pilots is cohesive maintenance. What happens here is the company that we work with developed this thing. You barely can see it. This is important because here is this gate. This gate is important. Like a car goes. I need a real microphone, guys. Okay, so you have this gate, and the gate has plenty of cameras on the left, on the right, on the top, and on the bottom. And when the car goes through it, there is gazillion of images, pictures taken that are of every little piece of this car. Okay? And those images are documentation of the state of the car. Let's say this is, parking at the airport. The car comes through this gate, and you have information how the car actually looked like. So later on, you cannot have somebody telling you, hey, you scratched my car. Well, you know, there are bad people there who bring their scratched cars to parking lots, and then on the way out, they say, hey, you scratched my car, you need to pay me. And then you have this thing, and you say, no, sorry, man. We have here full documentation of the state of your car, and there is nothing scratched on it. Forget it. Okay?
But this means that various locations, various stakeholders, various companies can use it to document the cars. We are talking car rental, we are talking parking lots, we are talking dealerships. When you come to the dealership, there are people who come with scratched car to the dealership, and then when they, for some repair, and when they get it back, they say, hey, you scratched my car. Of course, dealerships now know it, and they have smartphones, and they take photos. But this is an infrastructure that you just drive through and get the photos. But this introduces completely new set of requirements for the business process. What you have here is multiple stakeholders. Car rental, car parking, dealerships, production facilities, all of them can use one of those. Data processing cannot be done sometimes. Our partner says if there is a rush hour at the parking lot before a flight, then the cars, when they are passing, or in the dealership, when people are coming in the morning to leave their cars, there is no way the machinery can process machine learning. It only can collect the data as the car is passing through. By the way, if the cars are going out, you need to have very fast reasoning. You need to have immediately recognition of what's going on. So you cannot do certain things. This is the practice. This is not academic world in which you can do things in rounds.
Can you repeat this? 1 second. It takes 5 or 6 seconds. Yeah.
Okay, now I can do it. Okay, guys, so what we have here, multiple stakeholders, different owners of different scanners may not want to share their data. Hey, if you have two competing car rental companies, do you think that they will share their data? Of course not. But they need a joint image recognition model. All of those companies need to recognize where is the scratch, where is no scratch, and it needs to be extremely high quality recognition. So they have a reason to share it, but they don't want to share the data. They want the benefits of collaboration, but they still want to keep their privacy. They want to keep information. For instance, if car rental company A shared the data with car rental company B, then they would know how successful they are. So if one of those companies is less successful, they don't want to reveal it, but they want to share the updates to the model to be able to properly recognize scratched cars. or slight dents or little damages. Or maybe if you have photographs from underneath, you can recognize immediately that there is an oil leak. As the car is passing, it's doing the underneath inspection. Network bandwidth can be very heterogeneous. Some of those gateways may be in a place which has very good network connectivity, and the data will be passing through fast. Some of them may be in some not so well connected. It may not be the problem for this thing with the gateways, but it may be a problem in general. Heterogeneity is always a problem. Then you have devices, various servers on various sites with various companies will vary in their capacity. Some companies have less powerful servers. Some have more powerful servers. As I told you, sometimes devices are busy. You cannot do rounds. Because if you try to do rounds of training, you will not succeed. There may be specific topologies that you don't control. In academic research, we are assuming, oh, I can control my topology and I can run some experiments with this and that topology. Here topology comes to you. Okay? There's difference between academic work where you assume topology and reality where topology is given to you and you have to deal with it. You have to adjust your work to the topology you will find there. Okay? So, this all means that federated learning as a new discipline, by the way, federated learning, first paper is from 2019. I'm not kidding you. 19, 20, 21, it's even not 4 years old yet as the concept, as the research. But from the point of view of its actual applicability, it has to grow up. We need actual research in distributed environments. We cannot do experiments in the cloud. We have to realize that pre-processing has to be done. It is academic work starts with data which is pre-processed. Wrong. Pre-processing is part of the pipeline, and it has to be included in federated learning pipelines. Topologies may come to us, and we have to work with what's given to us. Learning process cannot be round-based. We cannot wait for laggards, for dropouts. We have to design methods. And maybe somebody of you will do this, will study this, will design methods that work when some nodes will not deliver updates in time, whatever time means. We also need to learn how to deal with constant flow of data. You know, in academic research, we have the, CFAR data set. Well, beautiful, we have CFAR. And what? What if there is a constant flow of data? And I think that one of the next speakers who is in the industry deals with situations, and this is extremely important. Data is flowing. You cannot tell data stop. And from now on, we have the perfectly trained model. No, we don't have perfectly trained models. Models will be evolving over time. Federated learning models have to modify themselves over time. Each day there is more data. So, this is all that I wanted to share with you. I hope that this was some food for thoughts for you. That there is a new discipline, which is named federated learning. The discipline responds to share without sharing in the context of machine learning, and I know that a lot of you want machine learning because you know that it will get you a good job. Yeah, if you are a data specialist, you can get a good job if you know machine learning. So this area needs a lot of additional work, There's plenty of work for all of you to get into, to make it applicable in actual industrial settings. Now, how to find me? If you want to find me, don't find me on Facebook. Because I have 2 accounts and both of them are already with 5,000 each. I have more than 10,000 friends. I have no clue who they are, but don't look for me on Facebook. If you look for me on LinkedIn. You can find me, and for those of you who are faculty members, with Professor Maria, we organized an absolutely beautiful conference that represents our style. By the way, this reminds me, the music that you had when there was the bouquet ceremony, I love it. This was great music, guys. It's kind of, I'm looking forward, by the way, if you have any ideas, connect me on LinkedIn and send me links to India-based folk heavy metal. Think about this. I want India-based, folk-based heavy metal from India. It can be even, like death metal based on folk songs from India. I'm looking forward to this, okay? At this moment, thank you all very much. And I will be here for this afternoon. I think there will be some session. So if anybody would like to talk to, well, next will be Professor Maria or myself. We will be here. Glad to talk to you. Thank you all. You have been a great audience.
Thank you, sir. Thank you, sir. Thank you, sir. Thank you so much. Do we have any questions for sir?
Yes, ma'am.
Okay, we do. Sir, maybe request you to please answer the question.
Who is the question?
Yeah, right there. We can pass the mic there.
Sir, I hope my voice is audible to you.
Yeah,
it is. Hello, sir. My name is Vertos and I'm a third year student in ICCS-2022. So, sir, over the past 2 years, COVID has impacted the industry a lot. In your lecture, you spoke about machine learning. So, I just wanted to ask you, what's the future of machine learning in healthcare industry? And how will it make a revolution there?
Okay, so there are 2 answers, the optimistic and the pessimistic. The optimistic answer of machine learning in health industry is great. You can do machine learning is great. It can do miraculous things. And if you read research papers about prostate cancer recognition using machine learning or brain tumor recognition using machine learning, and then you read about this study in which there was a certain number of images and the recognition quality is 97.25%. And we are all like, whoa, cool. And then you are finding out that the same model applied to completely different set of data that comes from some completely different place is useless. Because this model works very well for the data it was trained on. So, on the one hand side, definitely, we have to move on, we have to explore machine learning in healthcare. Because potential is there. but we need to be extremely cautious. We cannot believe the hype. You see, IBM. Who knows the name IBM? Do you know IBM? Yeah, you do, of course, yeah. IBM created a project which was named Watson, which was for machine learning for healthcare. They pumped gazillions of dollars into it. They hired hundreds of people. And you know what happened? It was last year or was it early? End of last year, they sold the whole project because they found out that after investing millions of dollars, seriously, IBM invested millions of dollars into Watson. IBM hired hundreds of people to work on Watson. They found out it simply does not work. They cannot deliver what they promised. So, yes, we have to, we should do more, we should understand better because we need it. No, at this moment, this is all hype and this is all marketing. Well, maybe not all, but majority of claims are hype and marketing. Okay? Anybody else has any questions? Maybe one more.
So much.
No, we don't have time. You see? But find me.
Thank you, sir. Thank you so much. Indeed, I must say that was the recipe of the perfect penny. And we go back with the basic note of sharing without sharing. Thank you so much for that, sir. I now request Professor Maria Ganza to please join us on stage. She's an associate professor at the Warsaw University of Technology, Poland. She has her MS and PhD degrees in mathematics from Moscow State University, Russia, and a Doctor of Science degree in computer science from Polish Academy of Sciences. Ms. Maria has published over 200 plus research papers and is on editorial board of 5 journals and a book series. She has been invited to program committees for more than 250 plus conferences and is a principal investigator of SRI-PST in the Inter-IoT project. Here, her team is responsible for the use of semantic technologies in the context of interporality of IoT programs. Welcome, ma'am.
Thank you. Can you hear me? Good, because I cannot speak so loud like my colleague Marcin. Okay, so I know that you're all very tired. Your mind is good for too much food, and your stomach not. So I will try to. Yes. Okay, let me start from a very short introduction of me, my university, and my city. I'm, as you have heard, I'm from Poland, and this is a beautiful picture from made from the drone, the center of the city during the night, very close to this center. My university is located. I discovered that it's more or less like your university. I mean, lovely professional university by size. It's around 40,000 students. It has been founded, as you can see, in 1915, so it's more than 100 years already. And on the left-hand side, you can see the picture of my faculty,
Mathematics and Information Science. It's a very young one. It's just 15 years I'm working there. And what I would like to share with you today is what we are doing there. It's a big part of what our students are doing. It's machine learning. So as you know, there are different types of machine learning. We can say every time when our neural network gives us an answer for the input, we can say, this is good. It's our feedback. And we call it supervised learning. Then another type of machine learning is unsupervised. We just get input to the machine and waiting what machine answer will be. Usually it's very popular right now for picture, for voice recognition. It's so-called deep neural network, or deep machine learning. And then one more time of machine learning is reinforcement learning. This is a very interesting domain which has more common things with how we training our animal or how we people are learning. It's based on trial, error, and collecting of our experience. So it's like human would like to know how to teach machine to think, to deal with reality like a human. It's also quite new domain. While it appeared many years ago, it's the first idea about such approach to neural network, to machine, how to do it, artificial intelligence. It was in 1950 around. It's Turing who told the first time about such approach. But honestly, during a long time, this idea was in the shadow. The first time when you probably heard about reinforcement learning, I think it was because of AlphaGo. When AlphaGo beat a world champion in Go. Do you know about this? Have you heard? You know what the Go was a game when the first program computer won a chess champion, Kasparov. Everybody, I mean, scientists claim that Go will never have such a program that computer could beat a human being.
Then, like 10, 12 years later, we have a program. And moreover, this program to teach himself by itself how to play in Go. And this is reinforcement learning. Couple of years later, like in 2018, I think the next success for reinforcement learning. And again, it's very loud about it. Do you know the game Dota? Who played in it? Okay, several people, yes. So, it was a competition. This is a team game. And suddenly, several computers, so it means several programs, discover how to play like a team. And the one of the best team in Dota. Of course, in not very full environment and so on, but it was amazing. The computer understood how the team works. So, just to remove magic from this, I would like to explain very shortly, don't be scared, very shortly and with a minimal mathematics, how it all works. Okay, very simple example, maze.
let's put our robot in the maze. Like, this Xiaomi vacuum cleaner, this roundish stuff which are moving here and there in the flat and trying or pretend to clean the flat. Okay, so how robot discover what robot has to do? What robot understand? Numbers. Robot can operate with numbers, can compare numbers. So, how we can explain robot what to do? Okay, as soon as robot moves to the next position where robot has to make a decision going left, going right, or going ahead, or to back, we give him a number. This position bring you this number. This is the information what we tell robots. Then, let's see what robot has to do. Just discovery of the shape of this maze, or to find the shortest way from this maze. If just discovered, good. As long our robot will be in the maze, as many new positions this robot will discover, this robot will receive more like numbers. We call it reward. But if we would like to say that our robot that find please the shortest way from the maze, we will put here some discount. The longer robot stay in the maze, the smaller reward this robot will get. And this is a very simple idea how reinforcement learning works. Simple? Not exactly. Why? Because the maze is a very simple example. This is the situation when a robot can assign to all its position the number. What will happen if the environment in which robot is working is huge and unknown? Like we sent our robot to the moon, to the Mars, to discover this planet. In this case, we got a little bit different methods. Methods which bring us the knowledge about only part of this environment. One of these methods is the Monte Carlo method. So we have many samples, like we put robot here, and robot discovered what happened around, put robot in another place, let's robot discover what is there, and then we calculated average knowledge. But still, it works very slow. What to do? Let's consider a very simple example. We have our home, our office, and we are going to go home. So we think that the road will, the way to go home, took us like half an hour. Then suddenly we discovered that this is rain. So we have to find some umbrella to go to the car, and in the rain, all the cars are moving slower. So immediately after leaving the office, we make a correction. Okay, probably the way home will take us like 35 minutes. Then there is a traffic jam or no traffic jam, and so on. Every time we are correcting our prediction. And this is a very similar method. We call it temporal difference learning, which are quite similar to Monte Carlo. But what Monte Carlo is doing, we are traveling home and then look back to our trip home. We evaluated how good or how wrong was our prediction. In temporal difference learning, we do it on every step. Rain, traffic jam, no traffic jam, and so on. And this is one of the fastest way how to teach our robot program agent to deal with unknown or model-free environment. Okay, but what if the environment is really huge? It's an image. How computer robot can understand image? From the other side, we know that deep neural network are very good in image recognition. So let's do the further things. Here is, do you know the game? What's the name of the game? Mario, yes. Okay. You are not sleeping, I'm just checking. This is the game Mario. And how the program which is responsible for Mario movement can recognize what to do, to jump or to go or to run. And we take a picture, put it in the neural network, recognize what is going on the screen, and then answer, based on this answer of this neural network, we command or make an order to Mario what to do. And this is so-called deep reinforcement learning, you see? And this is a very, very beautiful situation. So we have agent, Mario, he is in perfect state and waiting what to do. Neural network gave him a recommendation, jump. Mario jump, and then if he will, I don't know, hit in the wall, immediately neural network receive a feedback and can improve the result. And next time it will be more successful. Okay. So, I would like to make more realistic example. Look at this picture. I don't know if you can start this movie. And now the music will be.
This one, right?
Yes, yes. So, this is how this machine to park in the right place. We don't tell what to do. We just inform what action will bring this car like another reward. And put this car in different places. Of course, at the beginning, the situation is poor. Car is whatever. Pushing on the street. Probably, if you will be in a car with no lecture before, probably you will do the same. But then, many trials from different places with different fails.